NFPA70E is the standard for electrical safety in the workplace. Current edition 2018. This document is the interpretation for OSHA's rules, for all the prescriptive for compliance for the OSHA rules. Under 1910, Subpart S, Subpart R, and Subpart I. So all those OSHA subparts are actually placed together here inside of this document. If we look on the contents of this document, we have what's called an introduction, which is Article 90. This gives us basically the purpose and the scope. The purpose right there is standard: provide a safe working area for employees relative to the hazards in the workplace. Covered, virtually every activity you can think of in electrical is going to be covered by this document. Okay, how the document's arranged in 3 chapters, but now you got what are called mandatory rules, permissive rules, and explanatory material. Mandatory rules are the rules in the standard, or those that are identify actions that are specifically required or prohibited, characterized by the use of the terms shall and shall not. Every paragraph in this document is going to use terms for mandatory or permissive. Shall and shall not are mandatory. You shall do this, you shall not do that. Then you also have what are called permissive rules. These identify actions that are allowed but not required. They describe options, alternative methods. So identified as shall be permitted, shall not be required. Typically, if the standard mandatory rule cannot be used or followed, permissive rules are allowed. Now, the explanatory materials are going to be anything in a bracket. The bracketed material are references. They go to other documents. They're references, they're explanations, but they are unenforceable. They are not enforceable. That's going to be the introduction. Chapter 1 starts out with definitions. Now, under these definitions, there's a lot of people that will argue the terminology of just about anything and the meanings of just about anything you can think of. People just go out of their way for an argument. So right here, black and white, are all the definitions that are used by terminologies. To prevent the arguments, draw the line in the document. This is the meaning of this term as applied to these documents. So in other words, definitions are needed in many cases. So there's a lot of definitions dealing with just about every term you can think of as applied by this document. Then we get into Article 105, which is basically application of safety-related practices and procedures. This outlines a lot of what are called responsibilities. Who's responsible for what? Okay, now the purpose again is to provide safety for the employee workplaces. Now, responsibilities. Employer. The employer shall have the following responsibilities: establish, document, and implement the safety-related work practices and procedures required by the standard. Provide employees with training in the employer's safety-related work practices and procedures. So all the practices and procedures have to be provided by the employer. The employer has to train the employees. Now, Part B right here, employees shall comply with the safety-related work practices and procedures provided by the employer. So once the employer provides the procedures and practices, the employee is required to use them. But now look at 105. You've heard this one your entire working careers, guys. Prioritory. Hazard elimination shall be the first priority in the implementation of safety-related work practices. Have you ever heard the term shut off the power and lock out, tag out? Right there, that's the priority right there. Now, these are all the responsibilities. Then it goes into what's called general requirements for safety-related work practices. Well, right here, the electrical safety program, their employer, if you're going to work with electrical, that employer is required to have an electrical safety program that is in writing and can be accessible to any of the employees that need it. That program has got to cover a lot of points: inspection, condition of maintenance, awareness and discipline, program principles, controls, procedures, risk assessment procedure. Right there, this risk assessment procedure, you're going to go up to equipment. How do you know if it's dangerous or not? How do you identify if it's dangerous or not? So it has to have a step-by-step procedure. And that procedure has got to actually include things like human error. You have job planning, job briefings. Training requirements is 110.2. Now this goes into detail the training requirements for qualified persons and unqualified persons. Qualified persons are trained to one level, unqualified persons are trained to another level. So you got the training requirements. You have the lockout tagout procedure right there, black and white. Employees have got to be trained in lockout tagout. You have retraining procedures when people forget or they neglect. So there's all kinds of training procedures going through here. Now 110.3 goes into host and contract employers' responsibilities. The host employer shall inform contract employers of any known hazards that are covered by the standard that are related to the contract employer's work and that might not be recognized by the contract employer's employees. So in other words, the employer has to inform the contractor what hazards are present in that area. All hazards, not just electrical. Okay, the host employer's got to inform the contract employer of any information on the installation that the contract employer needs to make the assessments required by Chapter 1. This gets into electrical safety. The contract employer has got to make sure their employees are trained in any of the hazards that are communicated by the host employer. So the contract employer has to train his people. Documentation has to be made on training. 110.4 are test instruments. This goes into your meters and all the different types of test instruments. Just says they got to be rated correctly and inspected for use regularly. You got different tools for different locations. If anybody here has ever worked in areas that are in conductive and there's basically underwater or coated water, they're wet all the time, it can be a little bit more dangerous. So this requires tools rated for the areas and the use of GFCIs. Article 120 is your lockout tagout article. Lockout tagout has changed. It went from a 6-step procedure to an 8-step procedure for lockout tagout. So the entire article is basically rewritten, outlining responsibilities, principles, all the information for lockout tagout. Completely rewritten. Procedures, coordination, forms, the actual lockout tagout, simple procedures, complex procedures. These are all pretty straightforward. Simple procedure is what you do normally. You're going to shut off the equipment, you grab the handle, pull it down, turn it off, you put your lock, your tag onto it. When you're done with your work, you take your lock, your tag off. It's that simple. The complex procedure is different. You have multiple crafts, multiple equipment, multiple energy sources. It doesn't matter what it is. But there's one person physically in charge of locking and tagging everything. So this gets real complex, and there's lots of variations of each. Lots of variations. Now, we jump up to Article 130. This is where most questions are going to be answered in Article 130. Okay, the Article 130 right there, this identifies when the electrically safe work condition must be established, so when you have to lock out, tag out, and the requirements for work involving electrical hazards such as electrical safety related work practices, assessments, precautions, and procedures when the electrically safe work condition cannot be established. Let's dummy it up. If it's locked out, tagged out, it's considered as safe. If there is no lock on that equipment, it is considered as dangerous. So unless it's under lockout, tagout, it is considered as energized equipment. If it's not locked out, tagged out, it's considered energized. Right here, all requirements of this article shall apply whether the incident energy analysis is completed or if the tables are used in lieu of the energy analysis. What this is all about is how are you identifying the hazards and the calories and heat energy. If you've done that with an analysis of the power system, that's accurate. If you're using charts, which are general values, that too is not nearly as accurate. So it does not matter how you're picking out your PPE or how you conduct the analysis. All the articles of this article is going to apply. Now, energized work, additional hazards or increased risk. Energized work shall be permitted where the employer can demonstrate that de-energizing introduces additional hazards or increased risk. Well, you, the employee, demonstrate to the employer that you are competent in each and every task. That's a physical demonstration. How does the employer demonstrate that shutting off the power is more dangerous than leaving it on? The word is demonstrate. The only known method of the employer to demonstrate is what's called an energized electrical work permit. We'll get into that in just a little while. That's the only method the employer can do to demonstrate. But now, part 2 here, energized work shall be permitted where the employer can demonstrate that the task to be performed is infeasible or in a de-energized state due to equipment design or operational limitations. That is very easy for the employer to demonstrate. How do you take a voltage reading if the power is off? How do you measure current if the power is off? How do you take pictures of heat, thermography, if the power is off? How do you troubleshoot a PLC or a drive if the power is off? There are tasks where the power has to be on. So this gets into the energized work permit and all the elements that have to be on the permit. But there are exemptions to that work permit. Electrical work shall be permitted to be without an energized electrical work permit if the qualified person is provided with and uses appropriate safe work practices and PPE in accordance with Chapter 1 under any of the following. So in other words, as long as you wear PPE, no work permit is required for testing, troubleshooting, voltage measurements, thermography, access to and egress from work areas, general housekeeping, non-electrical tasks. So it's pretty straightforward in how that works. Now, we talk about boundaries. These are electrical safety boundaries. You have right here what are called shock protection approach boundaries from energized conductors or parts. Okay, this is based on voltages, phase-to-phase voltages. You have two boundaries, limited approach boundary, restricted approach boundary. The limited approach boundary breaks down into two categories. You have an exposed movable conductor. This is an individual wire that is exposed to being touched. Okay, for example, you have a panel board, the cover is off, there's a large breaker in the panel board, there are 3 welding cables coming off that breaker laying right on the floor, 3 individual welding cables. And those welding cables are feeding temporary power to a piece of equipment. Those are individual exposed movable conductors. Now, if those conductors are part of a cable assembly with an overall sheath, the rule does not apply. So this only applies to individual wires. Right here, most work takes place under exposed fixed circuit parts. This is where most work takes place, right under the exposed parts. The restricted boundary, this is where you're required to wear the rubber insulated gloves and the leather protectors. Now, these boundaries start out less than 50 volts. There are no boundaries specified because less than 50 volts is considered safe. That doesn't mean you're not going to get shocked. 48 volts will knock you on your butt. You're unlikely to die at less than 50 volts. But at 50 volts to 150 volts, you're going to keep unqualified people 10 feet from open wiring, 3.5 feet from live parts. You opened up a disconnect, a cabinet, equipment, panel board, it doesn't matter what it is, there's live parts. It could even be a junction box in a ceiling. You got to keep unqualified people a minimum of 3 foot 6 inches from live parts. Now, the average working distance is about 18 inches. So 3.5 feet would be somebody walking up behind you looking over your shoulder. You keep unqualified people a respectable distance away. When somebody crosses in these boundaries, a shock hazard exists. The restricted boundary is where you can get shocked by accidental contact and inadvertent movement. For 50 to 150 volts, avoid contact. Well, that means you don't have to wear the rubber gloves. But as we go further on, arc flash protection is going to be required. And arc flash protection will be a pair of leather gloves. So in all reality, you can work 50 to 150 volts AC or up to 300 volts DC wearing only leather gloves if the employer allows it. Most insurances will have the employer disallow that rule because you can get killed on 120 volts. So most employers will require rubber gloves at 50 volts and higher. Now, most work is taking place right here at 151 to 750 volts. Keep people 10 feet from open wires, 3.5 feet from live parts. You wear your rubber gloves at 1 foot 0 inches. So anytime you get within 12 inches of live parts, those rubber gloves need to be on your hands. These are your approach boundaries. So there's approach boundaries for AC power, there's approach boundaries for DC power. So those are basic boundaries. You got requirements for labeling. On your equipment right there, you should have a label on any piece of equipment that can be serviced. That label should include the nominal system voltage, the arc flash boundary, one of the following: the incident energy and the corresponding working distance, or the arc flash categories from the tables. It can also include the minimum arc rating of the clothing and a site-specific PPE. So it has to have one of those markings on that label. That's your equipment labeling. Now, do you need PPE? Do you not need PPE? Maybe, maybe not. This chart 130.5, estimate of likelihood of occurrence. If the equipment you're working with falls within these tasks under any condition of the equipment, there is no likelihood of occurrence of an arc flash. So no PPE required. But yet, if you're doing any task within this group, under any condition of equipment, yes, there is a chance of arc flash. So PPE would be required. So this kind of a chart goes back and forth. It's not complete, it's not specific, it's a general reference. Right here, operating of a circuit breaker, a switch, contactor, starter. Do you need PPE? If the equipment's operating normal, it's under normal condition, no PPE required. So there's basic charts and descriptions on when you need PPE and when you don't. Doesn't have to be rocket science. Now, there's a lot of employers who put arc flash labels on their equipment and, well, they don't put the description of the PPE that should be on that label. That's where this chart comes in. Incident energy exposures 1.2 calories up to 12 calories. This is your PPE. Incident energy exposures greater than 12 calories. This is your PPE. So the PPE, the matrix, doesn't have to be hard. We're going to get more into this. We go down the list. This is all Article 130. Now, right here is your testing for the rubber insulating equipment. Electrical blankets should be tested every 12 months. Electrically rated gloves should be electrically tested every 6 months. The daily air test is once a day. But every 6 months they need to be sent to a laboratory for electrical testing. Some people might even have their equipment there on their sites. What they do is they take the electrical gloves, they fill it with water. Okay, they fill it with water. They go ahead and drop the glove inside of a tank of water. The water tank right there has got a ground fault detector on the tank. They insert a high potential or a high pot test probe and apply 5 to 10,000 volts to the inside of the glove. If the ground fault detector turns on, well, the glove fails. If the ground fault detector does not turn on, the glove passes. So it's an electrical test. There are gloves that will fail right away, and there's some gloves that will last 20 years. All you got to do is take care of your equipment, but they do have to be electrically tested. You got a regulation identifying what clothing is not to be used. So you got limitations on clothing for electrical. Standards for electrical protective equipment. This one's kind of important here, guys. Here we have apparel, ARC rated. Standard performance specification for flame resistant and arc rated textile materials for wearing apparel for use by electrical workers exposed to momentary electrical arc and related thermal hazards. ASTM 1506. Every bit of your PPE, regardless what type of PPE it is going to have an ASTM number. Okay, now in today's world there's a lot of stuff coming from overseas that is counterfeit. What that means is it's probably not going to work. Probably not going to work. There's a lot of counterfeit stuff. This is why you have to look for the labels. On one of the labels on the clothing, you're going to see that ASTM 1506. If that label is on there, that clothing right there is good for arc rated for electrical workers. If that clothing is not on there, it is not for use for electrical workers. It's pretty straightforward. So you really should get to know what a lot of the standards are for the different types of PPE used, because there is so much counterfeit on the market today. Now here's your arc flash PPE categories for those people that do not have labels on their equipment. Panel boards, other equipment, 240 volts and below, maximum 25 kiloamps of fault current. Okay, the breaker clears in 2 cycles, working distance 18 inches, category 1 PPE, arc flash boundary 19 inches. Panel boards or other equipment rated greater than 240 volts up to 600. Maximum 25 kiloamps of fault current, breaker clears in 2 cycles, you're working 18 inches away, arc flash category 2 PPE. Arc flash boundaries 3 feet. So under these charts, there's a lot of people who don't have equipment labeled, so these charts are pretty well defaulted. Well, generally you got to have a pretty big facility to get over 25 kiloamps of fault current. Well, do you know if the breaker is going to clear in 2 cycles or not? All you got to do is look at it. If the breaker is discolored, it's probably not going to trip. If the breaker is broken, it's probably not going to trip. If the fuse is discolored, it's probably not going to trip. So it's a visual inspection to identify. But once you identify the type of PPE you need, now we can take the PPE from a chart. Here's your PPE matrix. The most common PPE you're ever going to run into is level 2. Arc-rated clothing rated a minimum of 8 calories. Arc-rated long sleeve shirt and pants or arc-rated coverall. Arc-rated arc flash suit hood or arc-rated face shield. If you use a face shield, you have to use the balaclava, the head sock. Arc-rated jacket, parka, rainwear, other hard hat liner as needed. Hard hat, safety glasses, hearing protection, leather gloves, leather footwear. There's your safety equipment, and it breaks down by categories by level. 4 calories, 8 calories, 25 calories, 40 calories. Now over here, the balaclava. This is the head sock. If you get an arc flash above 4 calories, that arc flash could wrap around the back of your head and set the back of your head on fire. So anything above 4 calories will require the arc-rated head sock, the balaclava. So there is a matrix right there for that PPE. There is a matrix. So we got more ANSI numbers. Then let's come over here. Let's go to the Annex J. Energized Electrical Work Permit. The Energized Electrical Work Permit. How does the employer demonstrate that shutting off the power is more dangerous than leaving it on? That's always going to be a gray area no matter what you do or where you work. Now, you're going up to an area, an equipment operator, machinery, an office area, it doesn't matter where you're at, and whoever's running that area or that equipment, you're going to tell them, hey, I got to drop your power, I got to kill your power for about an hour. They get pissed off and say, no, you can't, work it live. Well, one, why should you jeopardize your life because somebody else's inconvenience? Why should you put yourself in harm's way because somebody else's inconvenience? You don't have to. This has been a problem throughout industry for a long, long time. So now, it is your responsibility to go and get this permit. Okay, you could photocopy this one out of 70E, download it from NFPA websites. Your company might have a permit that's customized. Doesn't matter, it carries the same components. But you hand the permit to the person that told you no. That person is responsible right there to complete the top half. Equipment or job location, what needs to be done, and justify why the circuit or the equipment cannot be turned off. I've actually had one guy write in there, it takes 3 months to clean the injection machine. Well, that's pretty legitimate. Another young lady writes in there, if I'm late to the daycare, I got a $20 fine. Well, it doesn't matter what the justification is. That's justification for them. So it doesn't matter to you. Once this top part is completed, and good luck in getting somebody to complete that, the second part is completed by the person doing the work. It's actually pretty simple. Detailed description of what you're doing, identify the work practices employed, shock protection, arc flash protection, work boundaries. Then you do the results of a shock risk assessment and arc flash risk assessment. This you can copy from the label of the equipment or take it from the charts we just looked at. Very easy. You have to identify a restrict access unqualified persons. We set up a boundary at 10 feet. Provide a safety briefing if you're going to use one. You agree the work can be done safely, yes or no, and you and whoever works with you signs it. Now, the work cannot be done yet. The third part of this permit is approval. This has got to be done by management. Any manager, upper management can sign this off. Doesn't have to be these titles. It could be any title. But all it takes is one signature. And if you get somebody from management that signs this off, they're saying the power has to be on. There's no other way. They are identifying you as the qualified person to do the work. And they are going to take full responsibility for the work being done. So if the equipment gets damaged, whoever's name's on this list, that's the guy going to answer for it. Somebody doing the work gets hurt or killed, whoever's name's on this list, that's the guy going to answer for it. Highly unlikely anybody is going to sign one of these forms, and you get in upper management, these guys know better. They know a lot better. So it's highly unlikely for one of these forms to even get signed off. So in other words, guys, the NFPA70E system right there, these documents are an explanation of the OSHA rules. They're all the explanation of the OSHA rules. Okay, the documents right there, you can get them on NFPA.org. I would recommend NFPA for any of these safety documents. They're very good. Okay, you can get them at the Barnes & Nobles, the local supply houses, just about anywhere. But you really should have something like this right there accessible to all people that work.